All right, so in these problems, we're going to be reviewing graphing exponential functions. So in the lessons that you learned, we talked about horizontal asymptotes, we talked about the domain and range of exponential functions, and so forth. All right, and we also talked about what the graph of an exponential function looks like. Now, if we look at number one, we have 3 to the x minus 4. And so remember, when we first started talking about exponential functions, we talked about, well, what does that negative 4 do to the graph? What does that negative 4 mean? What part, what characteristic of the graph is this negative 4? Well, what I want to do is remind you about this. If this negative 4 wasn't there and all you had was 3 to the x, let's talk about that for a moment. So let's just consider, let's consider f of x equals 3 to the x. And so notice this is an exponential function. So remember, an exponential function, your base is a positive real number, and it's not equal to 1. Your base cannot be 1, and your exponent contains the variable. So if I look at this in terms of a t-table, just for a moment. So if I say if x is 0, I get y equals 3 to the 0, and 3 to the 0 is 1. So I get the point 0, 1. If x is, let's say, 2, well, let's do 1. If x is 1, I get y equals 3 to the first, which is 3. If x is 2, I get y equals 3 to the second power, which is 9. So I get the point 29. So these are ordered pairs. So these are ordered pairs on the graph of this function. If x is, let's say, negative 1, because we don't remember x here can be any real number. So remember the domain of an exponential function is all real numbers. I can use any real number for x. Positive numbers, negative numbers, decimals, fractions, rational numbers, irrational numbers. All right, so any real number for x is the domain. But we're going to be strategic with these. All right, so if x is negative 1, I get y equals 3 to the negative 1, which is 1/3. And so if I look at this in terms of the graph, so let me go ahead and just use this. So if I look at this in terms of the graph, I want you to notice something. So I'm going to plot these points, these 4 points on this graph. So if x is 0, my y value is 1, so I get 0, 1, which is here. If x is 1, we got y to be 3, and then I'm going to plot the 0.29, and then the ordered pair, negative 1, 1/3. So 1, 3 is here, 2, 9 is here, and then we're going to estimate this one, so that's a fraction. So negative 1, 1/3 is about here. Now, remember, in our lessons, we talked about this fact. So if we look at this function right here, notice that no matter what x value I use, my y values are always going to be positive. And notice that if I let x be negative 2, for example, I get y equals 3 to the negative second power, which is 1 over 3 squared, which we know is 1 over 9. So notice that these y values, as this gets smaller and smaller and smaller and smaller, these y values are getting smaller as well, 1/3, 1/9, and so on. And so this side of the graph gets closer and closer to this x-axis, and that x-axis here is our horizontal asymptote. That's our horizontal asymptote. And so we get something that looks like this. Okay, so that is the graph. That is the graph of f of x equals 3 to the x. But what I want to do, though, is I want to graph this. I want to graph f of x equals 3 to the x minus 4. Well, remember, in our lessons, we talked about the idea of transformations. And so I'm going to use this. I'm going to overlay this. So these are the same graphs. All right. So this function here, so the question is, what does that negative 4 do to this graph? Well, remember, that negative 4 shifts it down 4 units. So when I graph this, 1, 2, 3, 4, when I graphed this, my horizontal asymptote, all these points were shifted down 4 units. All right, so when I graph f of x equals 3 to the x minus 4, this will be the graph I will end up with, a red graph. where the horizontal asymptote is at y equals -4. So the point's this now. So the point's this. So this -4 here, that's your horizontal asymptote. That's your horizontal asymptote. Now remember, when we graphed this was plus 0, right? That was plus 0. And so your horizontal asymptote here, your horizontal asymptote, asymptote, horizontal asymptote is y equals 0, which is the x-axis. And that's what I graphed here. Right here, that was the x-axis. So your horizontal asymptote is y equals 0. So your horizontal asymptote here is going to be this -4, but you got to say y equals. You must say y equals -4. Don't put just -4. You're not going to get all your points. All right. Now to find the y-intercept, here's how you're going to find the y-intercept. So remember to find the y-intercept, so this is part A. To find the y-intercept, you're going to let x equal 0, right? So let x equal 0. So if x is 0, I get y equals 3 to the 0. So where we see the variable x, is substitute 0. So 3 to the 0 minus 4. Well, 3 to the 0 is 1. 1 minus 4 is a -3. So I get the point, so I get the y-intercept to be -3. Now remember, the domain of all exponential functions, is all real numbers. So that's going to be -infinity to infinity. Now let's do the range after we start looking at the graph. Now let's go to part E. So part E, they want you to state two other ordered pairs on the graph. Well, that's just using that t-table and just finding other values for x and y. So state two other ordered pairs, and you use this information to help you graph the function. So we already have x to be 0. So x to be 0 is negative, y is -3. So I need two other ones though. So let's say x is 1. So I get y equals 3 to the first minus 4. Well, 3 to the first is 3. 3 minus 4 is a -1. I need one more. So right now I have the point 1, -1. Okay, so you must list it as ordered pair. Let's let x be 2. So if x is 2, I get y equals 3 squared. So remember, where we see the variable x, you substitute 2. So 3 squared minus 4. So 3 squared is 9. And 9 minus 4 is 5. So now I have the other ordered pair 2, 5. And I'm going to use this information, to help me graph f of x equal 3 to the x minus 4. Okay? So the first thing I know is that the horizontal asymptote is y equals -4. So we're going to draw the horizontal asymptote. So make sure you do that. Remember that dotted line, y equals -4. And then we're going to use these points here to help us to draw the graph. So I know that my y-intercept is -4. I'm sorry, -3. My y-intercept is -3, so that's here. Put a dot here on -3. And then I have two other points, 1, -1, and 2, 5. So 1, -1, and then 2, 5. And then remember, your graph gets closer and closer to the horizontal asymptote, just like this, and on this side it rises rapidly. And so that's the graph of f of x equals 3 to the x minus 4. Now let's now talk about the range. So remember the range is a set of y coordinates. So I'm going from this horizontal asymptote. Now remember, the graph never, the y value is never -4. It gets closer and closer to -4, but it's never -4. So you're going to say -4 all the way to infinity. But when you do the range for exponential functions, since that's a dotted line here, you're going to use a parentheses. You're going to say -4 to infinity. And so that was number 1. Okay, so let's look at number 2. Okay, so this is number 2. Now this time we have f of x equals -3 to the x plus 5. So f of x equals -3 to the x plus 5. So the first thing I want you to do is find the y-intercept. So let's talk about that, the y-intercept. So to find the y-intercept, we're going to let x equal 0. And so if x is 0, wherever we see the variable x, I'm going to substitute 0. So I get y equals negative 3 to the 0 plus 5. Now be careful. You remember the only thing that's being raised to the 0 powers is 3. So 3 to the 0 is 1, so this becomes a negative 1. So negative 1 plus 5, which is 4. And so right now I can go ahead and plot that y-intercept. So I know that my y-intercept is going to be, the graph's going to cross the y-axis at 4. So I'm going to put a little dot here. Now the next question is this. The next question is, what's the horizontal asymptote? Remember, the horizontal asymptote is this number. So your horizontal asymptote is this right here. So in part B, you're going to say the horizontal asymptote is y equals 5. So right now I'm going to go to the graph. I'm going to go to the graph and I'm going to put the horizontal asymptote, the dotted line, at y equals 5 right here. Okay? All right, so that's my horizontal asymptote, y equals 5. All right, now the next part, so I'm going to put y equals 5. So you must say y equals 5, and then the y-intercept here was 4. The domain, remember, the domain of all exponential functions is all real numbers. Now let's come back to the range in a little while. Let's do this next. So let's take two ordered pairs on the graph of the function. So this is going to be E. So in E, I'm just going to use a t-table, and I'm going to let x be, let's say, 1. If x is 1, I get y equals, wherever we see the variable x, I'm going to substitute 1. So I get negative 3 to the first plus 5. Well, remember, be careful. 3 to the first is 3 is the only number that's being raised to the first power, and whatever that is will be negative. So 3 to the first is 3, so that becomes negative 3. Negative 3 plus 5, which we know is 2. So I get the point 1, 2. All right, so I'm going to go ahead and plot that point 1, 2. So here's 1, 2 right here. Okay, and let's do one more point. So, and don't forget, always go back and make sure you put it as an ordered pair. So 1, 2. Now let's go ahead and let x be 2. So if x is 2, I get y equals negative 3 squared plus 5. Well, 3 squared is 9, so this becomes negative 9 plus 5, which is negative 4. So I get the point 2, negative 4. So again, plot that point 2, negative 4, which is right here. And so we can graph this now. So the graph, remember the graph on this side is going to go towards the horizontal asymptote without touching it, because remember these y values will never be the horizontal asymptote. It gets closer and closer to negative 4. I'm sorry, negative 5, excuse me. And on this side, it falls rapidly. So there's the graph. So that's the graph of, this is the graph of f of x equals negative 3 to the x plus 5. All right, now from there, we can talk about the range. Let me go ahead and state this point. So that was a point 2, negative 4. So the range, remember, you go along the y-axis. And so when I do that, when I go along the y-axis, I'm going, see, this time the graph is below the horizontal asymptote. So when I go along the y-axis, I'm going from negative infinity all the way to this horizontal asymptote, which is at negative 5. So your range is going to be from negative infinity all the way to negative 5. So you're going to say negative infinity to negative 5. Remember, parentheses are negative 5 because the y value, this y value is never going to be negative 5. It gets closer and closer to negative 5. All right. Now remember, the reason why it's below the horizontal asymptote is because of this negative out here. So remember that negative is a reflection about the horizontal asymptote. So when we talk about, when I go here, I'm going to go remind you about this. So remember earlier we looked at this graph here. So if I wanted to look at y equal f of g of x equal negative 3 to the x, negative 3 to the x. Remember, this is f of x equals 3 to the x, which is this right here. All right, so remember in our lesson we talked about the idea of that reflection. So here's my horizontal asymptote. So if I reflect this graph about that horizontal asymptote, I get this. And so that's that graph here. Now remember, so this graph is this right here. But remember, I'm shifting it up 5 units. So remember right here, I'll remind you about this. So that plus 5. So you're shifting it up 5 units. So you're going to go 1, 2, 3, 4, 5. And that red graph is the graph that you see here. Okay? So basically, remember this right here is the graph of let me go ahead and do this. Okay, that's the graph of f of x equals 3 to the x. If I reflected about that horizontal asymptote, which is this now, I get this graph, but then remember you're shifting it up 5 units, and so you're going to get this now. Okay? All right, so that was number 2. Okay, now let's look at number 3. So number 3, we have this. We have this function, number 3, and we're going to rewrite it right here. So f of x equals 1/2 to the x minus 5. All right, so first of all, let's find the the y-intercept. So the y-intercept, you're going to let x equal 0. And so if x is 0, I get y equals, so where we see the variable x is substitute 0. So I get y equals 1/2 to the 0 minus 5. Well, 1/2 to the 0 is 1, and 1 minus 5 is a negative 4. So I know that the graph is going to cross the y-axis at negative 4. All right, so right now, if you want to, you can go ahead and put a dot. Oops, sorry. You can put a dot at negative 4 right here. We also know that the horizontal asymptote is this number right here. So the horizontal asymptote is this negative 5. But you got to say y equals negative 5. And then from there, you can draw the horizontal asymptote. So make sure you draw the horizontal asymptote on your graph. So the horizontal asymptote is y equals negative 5. So draw your dotted line right here at negative 5. Okay. And then the domain, remember the domain of all exponential functions are real numbers. Now let's come back to the range after we draw the graph. Now let's do 2 other ordered pairs. Now, so for that one, see this is a fraction. So you're going to end up with a fraction possibly depending on what number you use for x. But I want you to remember something. So if x is, let's say, 1, if x is 1, I get y equals 1/2 to the first power minus 3. Oops, sorry, minus 5. And 1/2 to the first is 1/2, and then 1/2 minus 5 is negative 4.5, right? Negative 4.5. And so I get the point, 1, negative 4.5. Now, if I plot that point, I want you to see something. So here's negative 1, 4.5, which is here. Okay? And so on this side, the graph gets closer and closer to the horizontal asymptote. So let's see what happens on this side. So on this side, we're gonna have to pick some negative numbers. So let's say negative 1. So if x is negative 1, I get y equals 1/2 to the negative 1 minus 5. Now remember in a previous course we talked about negative exponents. So if I want to make this exponent positive, I need to take the reciprocal of this 1/2. So it becomes 2 to the first minus 5. Well, 2 to the first is 2, and 2 minus 5 is a negative 3. So I get the point negative 1, negative 3. So negative 1, negative 3 is right here. And let's just do one more, although that was enough. I mean, you could, that'll be fine, but I just want to do one more just to make it look a little bit better. So if x is, let's say, negative 2, I get y equals 1/2 to the negative 2 minus 5. Well, remember, to make that exponent negative, I got to take the reciprocal of this base. So the reciprocal 1/2 is 2, so I get 2 squared minus 5. Well, 2 squared is 4, and 4 minus 5 is a negative 1. So I get the point negative 2, negative 1. So negative 2, negative 1 is here. And so I get something that looks like this. And just do the best you can with drawing that graph. So that's the graph of f of x equals 1/2 to the x minus 5. All right, let's talk about the range. I forgot about the range. So the range, remember, is a set of y coordinates. So when I talk about the range, I'm starting in this horizontal asymptote. Remember, the graph, the y value gets closer and closer and closer to negative 5. So I'm going from negative 5 all the way to infinity. But remember, when you do the range, though, since the y value is never negative 5, it gets closer and closer to negative 5, I have to say parentheses negative 5 to infinity. All right? And so that is the review of exponential functions. Okay, so that's a review of exponential functions.